Welcome to a course on sequence and series. In this lecture, we are going to talk about Raabe's test. This is also called as higher ratio test. Okay, when is the situation we will make use of this Raabe's test? We will make use of this test whenever d elements ratio test fails. That is, when the limit is 1, the test d elements ratio test fails, and at that situations we may make use of Raabe's test. Here, in order to make use of this test, what is the need? We must need a series which is the series of positive terms. Okay? Then we are going to find out the limit of n times of un upon un plus 1 minus 1 and is L. Okay? Here, based on the value of L, we are going to see the convergence, right? If L is bigger than 1, the series converges, right? And if L is smaller than 1, the series diverges. And if L is 1, the test fails. That is, it fails to give you about the convergence. Okay. Now let us see an example to illustrate this. Consider the series x upon 1 plus 1 times of 3 upon 2 times of 4 and x cube upon it is 1 upon 2 x cube upon 3, then 1 times of 3, 2 times of 4, x power 5 upon 5 plus 1 times of 3 times of 5 upon 2 times of 4 times of 6, x power 7 upon 7, and it goes this way. This is the series that we have considered. Now we will have to check the convergence of this series. Now let us try and identify the general term un here. Okay, for which you just look at the terms. When your n is 1, what you have simply x upon 1. It means you will have x upon something is going to be there, right? When your n is 2, you have 1 upon 2 and x cube upon 3. We will have to associate 2 with 3 by some means, here 1 with 1 by some means. And when we look at the third term, we will have to associate 3 with 5 by some means. That can be easily done using 2n minus 1, right? If you give n is equal to any value, you are going to get this thing. The same power is in the denominator as well, so it is going to be x power 2n minus 1 upon 2n minus 1. Okay. Along with this, we have something in the multiplication part. What is it? Okay. In the first term, we don't have anything. Let us leave it. Okay. In the second term, we have only 1. 2 has to be associated with 1 and 2 has to be associated with 2 also. Okay. Something is there. Okay. Fine. 3 has to be associated with what? 1 and 3. And 3 has to be associated with 2 and 4. So it means what? Whenever you keep increasing the number of terms, in all the terms, first we have this 1 upon 2, then we have this 1 times of 3 upon 2 times of 4, then this thing is there, along with this we have something else. So it is going to be 1 times of 3 times of 5 times of, it is going this way. Until what term we have, that is a question mark, right? So when your n is 4, you have till 5. So, and how we have associated this 4 with 7, 2n minus 1, right? So when you make 2n minus 3, you get this, and when you make 2n minus 2, you get this, right? Your 2n is 8, 8 minus 1 is 7, 8 minus 2 is 6, 8 minus 3 is 5. Similarly, if you check with this term, your 2n is 6, 6 minus 1 is 5, 6 minus 2 is 4, 6 minus 3 is 3. So what are we having? 2n minus 2 in the denominator and 2n minus 3 in the numerator. So this is the term un. Then what would be un plus 1? In all the places of n we will have to substitute n plus 1. So it is going to be 1 times of 3 times of 5. It goes till 2n minus 3 times of 2n minus 1. Right? Upon 2 times of 4, 6, and it goes till 2n minus 2 times of 2n, and here what will we have? X power 2n plus 1 upon 2n plus 1. Right? So this is what we have. Now let us calculate un plus 1 upon un. So whatever may be the given problem, first we will have to do D-elements ratio test. And we will have to see the convergence of the given series using D-elements ratio test, and when the test fails, we will have to make use of this Raabe's test. Okay, that is why we are doing D-elements ratio test now. Okay, what is it going to be? It is 1 times of 3 times of 5, and it goes till 2n minus 3 times of 2n minus 1 upon 2 times of 4 times of 6, and it goes till 2n minus 2 times of 2n, and x power 2n plus 1 upon 2n plus 1, and we have what? 1 times of 3 times of 5, and it goes till 2n minus 3 upon 2 times of 4 times of 6, and it goes till 2n minus 2 times of x power 2n minus 1 upon 2n minus 1. Now if you see, you can cancel this with this and this with this, right? And this can also be cancelled, and you will left with x square. So what you have in total? So what you have is 2n minus 1 upon 2n, right? And this goes to the numerator, and this still remains in the denominator. So 2n minus 1 upon 2n plus 1, right? And you have x square. Right? Here what is going to happen? You just try to bring out x, all the n's outside, and see what happens. So if you take n outside, you will have 2 minus 1 upon n. Here if you take n outside, 2 minus 1 upon n. Here we have 2n. If you take n outside, then we are going to have what? 2 plus 1 upon n times of x square. These n's gets cancelled. Now let us take limit n approaches infinity to this un plus 1 upon un, and we see that when we make n approaches infinity, this term will be 0, this term will be 0, this term will be 0, and we will be left with what? 4 upon 4 times of x square. It is simply x square. Right? We are getting x square. So based on the value of x, the convergence is going to take place. Right? By D-elements ratio test, if x square is less than 1, summation un converges. Right? If x square is bigger than 1, summation un diverges. Now the question comes when x square equals 1. We have seen these two cases, right? Okay, when x square equals 1, your D-elements ratio test fails. In that case, we are going to make use of Raabe's test. Okay, when x square equals 1, what is going to be un plus 1 upon un? Right? Here, this was our un plus 1 upon un, right? Okay, we have to substitute x square is equals 1, therefore it is going to be simply 2n minus 1 whole square upon 2n times of 2n plus 1, right? This is what we have. Now we need this thing to proceed with this, right? And this is going to be what? Simply 2n times of 2n minus 1 upon 2n plus 1 upon 2n minus 1 whole square, right? And we will see where does it take us to. we have that, and we will have to multiply n with it, right? So we are multiplying n, and it is going to be 2n plus 1 upon 2n minus 1 whole square minus 1. This is what we have, right? So this is the term that we have to evaluate, right? And let us write this as n times of, let us multiply it inside. So we are going to get what? 4n square plus 2n, and when you take LCM, what you are going to get? You are going to get 2n minus 1 whole square upon 2n minus 1 whole square. So this is going to be 4n square plus 2n minus 4n square. I am just applying the formula a minus b whole square. So minus 1 plus 4n upon 2n minus 1 whole square, right? This 4n square minus 4n square gets cancelled. So what am I going to have is that n times of 6n minus 1 upon 2n minus 1 whole square. Now take n outside. So what are you going to get? N square upon 6 minus 1 upon n upon, if we take n outside, so we have square, so it is going to be n square upon 2 minus 1 upon n square. N square gets cancelled. When we take limit n approaches infinity, what are we going to get? N times of, this is what? Un upon un plus 1 minus 1, and this is going to be 6 upon 2, which is 3, and this quantity is bigger than 1. So when we have this quantity to be bigger than 1, hence summation un converges for what case? When x square equals 1. Combining all together, we may conclude that summation un converges for x square less than or equals 1 and diverges for x square bigger than 1, right? Thank you for watching.